Okay, in this video we're going to solve the trig equation 2 sine squared x minus 1 is equal to 1 over the secant of x. And we can see in our trig identities hexagon here that secant is the reciprocal of the cosine. Remember, those reciprocal relationships are on the diagonal. So we're going to apply that reciprocal identity to replace 1 over secant of x with the cosine of x. Our goal is to rewrite this trig equation in terms of just one trig function, and we can change a sine squared x into cosine squared x using a Pythagorean identity, and that identity would make this triangle in the top of our hexagon. Sine squared x plus cosine squared x is equal to 1 squared. So if I solve that for sine squared x, that means I can replace this with 1 minus cosine squared x using that Pythagorean identity. Then to evaluate these parentheses, we'll distribute, and we'll have 2 minus 2 cosine squared x minus 1 equals cosine of x. And that's quadratic. We have a quadratic term, a linear term, and a constant. So let's set this equation equal to 0 by adding 2 cosine squared x to the other side, subtracting over the 2, adding over the 1, and then 0 equals 2 cosine squared x plus cosine of x, and then minus 1. Okay, we can factor this quadratic trinomial into a 2 cosine of x with a 1, a cosine of x with a 1. We want the middle to be positive, so we'll put our minus and our plus in like this, and then we can apply the 0 product property to set each factor equal to 0 and solve for x. So 2 cosine of x minus 1 equals 0, or cosine of x plus 1 is equal to 0. And those would be the 2 separate equations that we're going to solve from there. So starting with 2 cosine of x minus 1 equals 0, we're going to add 1, divide by 2, and then to get the x by itself, we'll need the inverse, which is the arc cosine of positive 1/2. And that's asking us to find on the unit circle whatever angles have an x coordinate of 1/2. And that would be at pi over 3 as our principal value in quadrant 1. And then all students take calculus. Cosine is also positive in quadrant 4, which would be 5 pi over 3. And that's 2 solutions that we can check. Now let's turn to the second factor, cosine of x plus 1. We set that equal to 0, and we want to solve for x again. So we'll subtract 1 from both sides, apply that inverse to both sides to get x by itself. And x is the arc cosine then of negative 1. And that's asking us what angles on the unit circle from 0 to 2 pi inclusive have an x coordinate of negative 1, and that would occur at pi. So that's our third solution that we want to check. So let's go ahead and get our calculator situated here, and we're going to make sure that we're in radian mode, and we are. So we'll start by typing in pi over 3, and we'll store that as the x, and then we'll type in our original equation, which is 2 sine of x, that trig function is squared, then minus 1. Then we need the equals from the test menu, and there is no button on the calculator for secant, so we're going to use the reciprocal identity. 1 over secant is the cosine. Okay, we press enter, we get a 1, which tells us that pi over 3 checks. Now let's check 5 pi over 3. We'll store that as our new x, arrow up to the equation so we don't have to retype it. Press enter, we get a 1, so 5 pi over 3 checks. And then pi, we're going to store as x, and then arrow up to that equation again, and we get a 1. And so this equation has 3 solutions, pi over 3, 5 pi over 3, and pi.